The graph of a function. The graph of a function. This is section 2.2. We first recall what we call them the parent functions. Y equals x. How does the graph look like? Is the line that goes through the origin like so. This is y equals x. Always label the x, the y-axis, the x-axis, the arrows, the origin. We have y equals x squared. That's another one of those parent function that looks like a U shape like that. So we always assume you already know it without plotting points or anything like that. Y equals x cubed. That's another parent function. The graph goes up this way. We have y equals the square root of x. The graph goes this way. Those are parent functions. Now what we need to do is we need to check, which we did earlier in the previous section, to check if is a given graph a function or not, or does it represent a function or not. To do so, we use the vertical line test. We use the vertical line test. So let's say we are gonna sketch several graphs. We always label the functions or the graphs. Label the x-axis, y-axis. So we're gonna test which one of these represent a graph of function. To do so, we use what we call the vertical line test. If you draw a vertical line, notice it intersects at more than one point, so it's not a function. For this one, no matter where you draw the vertical line, it's always 1 point. Yes, a function. Same thing here, yes. If you draw vertical lines like that, yes. If you draw vertical line, no, it's not a function. Next, let y equals f of x. Take an example of a function like that. As we did in the previous section, let's try to find the domain first. Domain for this function. Since it's a rational function, means something over something, that denominator cannot be 0, so x cannot be 2. So the domain is all real numbers except 2. Some people write like this. It's called set notation. X means the domain is all real x values such that, so this slash here means such that, or some people write colon like this, such that x cannot be 2. This is called set notation. Set notation. In the interval notation, on the number line, this is the 2. So you can have anything but the 2, means you can go from negative infinity to 2, union 2 to infinity. This means this notation tells us it skipped over 2. That's called interval notation. Interval notation. That's the domain. So when we graph this function, for example, at 2, we're not going to have a graph at 2. Next, we're trying to find the intercepts. Intercepts means where the graph of this function is going to cross the x-axis and where is it going to cross the y-axis. So remember, the function was 2x over x minus 2. So to find the y-intercept, first, we set the opposite. We set x 0. What does that give us? 2 times 0 over 0 minus 2. So that's a 0. So we have 0, 0. X-intercept. we set y 0. When you set y 0, 2x over x minus 2. Cross multiply, so 2x is 0, x is 0. So that gives me the same point. So the graph of this function is going to go through the origin. Another part to this, if x equals 4, what is f of x? So what are we going to be doing here? We're going to just take the function, rewrite it, f of x equals 2x over x minus 2. X equals 4 means we need to find f of 4 when x is 4. 2 times 4 over 4 minus 2. And this one would be 8 over 2, which is 4. So that gives me when x is 4, y 4. Let's add another part. Is the point 1/2, negative 2/3 on the graph of f? We can test that out without actually graphing it, Let me write the function again. Y equals 2x over x minus 2. So the y is negative 2/3. Is that going to be 2 times the x is 1/2 over 1/2 minus 2? That's what we're going to be testing to see if it works or not. Will negative 2/3, I can't do anything on the left side, but the right side, these cancel, I get 1 over. If you combine these by multiplying by 2, you get 1 minus 4. Is negative 2/3 the same as 1 over negative 3/2? Well, it flips the fraction. Yes, they are the same. So that tells us that that point is really on the graph. If f of x equals 1, what is x? That's another part to the same function. How do you find the value of x? So we have f of x is 2x over x minus 2. They give us that this is 1. So how do you solve for x? You cross multiply. 2x equals 1 times x minus 2. Subtract x on both sides. That gives me exactly what I want. Now we are going to look at a given graph. Like this one. This is the graph of f. So this is the graph of f. And this graph starts somewhere at -5, -3, goes through a point -2, -1, through the origin to 1, up to 4, 4, and then goes down to 6, 0. This is a graph of a function because it passes the vertical line test. If you draw vertical lines, it intersects this at exactly 1 point. Now we need to answer these questions. What's the domain? Remember, domain has to deal with the x values. So if you start from the left to the right, you're going to hit the graph at exactly -5, x equals -5, and it goes all the way to x equals 6. So that's the domain. For the range, from the bottom up, so when you draw a line from the bottom, so you start at -3, and this goes all the way up to 4. So that's -3, 4. That's the range. Now, when is f of 0, or what does f of 0 equal to? So it means when x is 0, what is y? Well, it's 0 because it goes through the origin. How about f of 2? When x is 2, y is 1. When x is 2, y is 1. What are the intercepts? The intercepts means where the graph crosses the x-axis and the y-axis. So for I see 0, 0 is one of them. And also it's 6, 0. This is another one. These are the only ones where they intersect the x-axis and the y-axis. So 6, 0 is the x-intercept and 0, 0 x-intercept. Also 0, 0 is the y-intercept. For what value of x does f of x equals -1? So this means when y is -1, what is x? Let's look at which point has y -1. See this point here, y -1. So x is -2. So in this case, x is -2. is f of 3 positive or negative? F of 3 means when x is 3, is the y value of x equals 3 positive or negative? Let's check it out. When x is 3, you see the y value is somewhere here, so it's positive. I don't know what that is, but we just know it's positive. For what values of x is f of x less than 0? F of x less than 0, it means y less than 0. Y less than 0 means below the x-axis. When is the graph below the x-axis? Well, let's see. It's below the x-axis. Let's see. When x is going to be from -5 all the way to a little bit below 0, a little bit before 0. So it's exactly -5. That's why we put a bracket to 0 parentheses, means right below 0, right before 0. But if they say less than or equal, this means not just below and on the x-axis. So in this case, it's not, it goes from -5 exactly to 0 exactly there. 0. And not only that, actually, you can remember also the graph hits the 6 0, so you can put a union, the 0.60, so also 6, the 0.6, this 6 here, this one. So it goes from x exactly equal -5 to exactly 0, and also union means you combine them as well, also 6, because you have to jump all the way. That's how we find it.